Ready? One. All right, so we're recording Emma and Mackenzie. This is sixth period. If you're listening, we miss you. We hope you get better soon. It is September 27th, National Chocolate Milk Day, and it is Lil Wayne's birthday. He's only 39 today. He looks a lot older, doesn't he? Yeah, I know, right. Now, speaking of older, I have a story. My dad is an only child. He was born late. I think my grandfather was like 60 years old when my dad was born. And they knew they were only going to have one kid. So they used up all their names on my dad. His name is Wayne Russell Joseph Michael Corby. Right? He has like 22 middle names. But his first name is Wayne. And that's my middle name. Now, growing up, he was like 6'4", you know, kind of big and brawny. And I used to fear him. You know, he would be like, get over here. And he'd grab me and he'd whip me. Boom, boom, don't do that. Right? I was like, I'm scared of you. Right? Fear. I respected him. But he's getting older now. He's 75 and he has osteoporosis. Yeah, they give it up. And his like his mother. So his bones are getting brittle and frail. And he's actually developing like a hunchback. So he's kind of like getting shorter. So he used to be like 6'4", and now he's like 5'9". You know, he's lost like 8 inches in height. So now he's like up to here. And now when I see him, I don't even call him Dad. I call him Lil Wayne. So this is Lil Wayne. Hey, let's go see Lil Wayne. And yeah, he was Big Wayne, Big Brawny Wayne. And I don't even think he knows who the rapper is. He just thinks I'm being cute. So he's like, oh, thank you. I'm like, hey, Lil. He wasn't like Big Daddy. Now he's like Lil Daddy. And back in the day, I was scared of him. But like now I look at him like, I could give that guy the works if I wanted, you know. I mean, I could, man, you know. So I'm not afraid of him anymore. But anyway, Lil Wayne, my dad. Hey, on this day in 1908, Henry Ford's first Model T, it left Detroit. No one where when it went or who took it, but it just left Detroit. Right? And where did it go? Anywhere but Detroit. Maybe so, yeah. But anyway, he built his first Model T off the line. And the word of the day sounds like Chernobyl, but it's Chernozem, which is a soil common in cool, temperate, or arid soils. Okay, so yeah, Lil Wayne's having a birthday. Is anybody in here having a birthday today? Because remember, we like to celebrate. Hey, we're off this week, so no pep rally this week. But our next pep rally will be a candlelight pep rally out at the stadium for homecoming. So, okay, first things first, before we get to the warm-up, your test is now going to be on Thursday instead of tomorrow. That was an executive decision that the Precal boss, Mrs. Lincoln, made, and I'm fine with that. It's going to be on section 1.1 to section 1.3 and section 2.1, but only through example 7, as we already said. So that is called the section symbol. Some people asked about that. Like, what is that symbol? It's like 2 spooning S's, right? Ooh, ew, ew. Don't make it gross. They're fully clothed, and it's a platonic relationship. Okay? Okay, I probably took it too far, but that helps you when you're drawing them, maybe. All right? So here's the deal. Your worksheet, you want to make sure you're doing your worksheet, but it is not going to be due on Thursday. Thursday is, by the way, the last day of September. It's the 30th, okay? And then October comes, right? So your worksheet is going to be due when we take our next test. Now, because it's a 9-week grading period that only has 8 weeks, and the first week, Stephen, was just taken up with like, here's the syllabus. Any question? What's 1 + 4, right? We kind of lost that week. So it's really like a 7-week, 9 weeks grading period. And because it's a level 3 class, I have to give another test before the end of the 9 weeks and still allow time to retest. So, whoa. So we're probably going to test again next week. And you're like, really? And I'm like, yeah. So this test on Thursday will be through 2.1 example 7. After the test, we'll finish 2.1. We'll talk about holes and vertical asymptotes, which is, there's quite a bit of information there. And then we'll test again. So your test will not include holes or vertical asymptotes. So as you're going through the worksheet, are you working practice tests, remember? Practice tests. If you see any question that says hole or removable point discontinuity or vertical asymptotes, just be like, nah, don't worry about it. You will have to find domain though, okay? So, any comments or questions before we jump into the warm-up and jump into example 5 afterwards? All right, here we go. There's two things we're trying to avoid. That's it, just two. Can't divide by 0, can't take square root of a negative. If you have both of them in the same problem, here's what you want to do. Treat them as two separate cases, and then intelligently and nicely, amicably, combine your results. Now, it doesn't matter which one you start with, but if you have no preference, may I say or encourage you to use the Radicand first, because the Radicand is trying to avoid a special type of number, negatives. So it, by nature, excludes infinitely many values, and therefore includes infinitely many. So it's going to give you the chunk of your domain, okay? So start with the Radicand if you can. Now, here's what we do. We take the entire Radicand, which is everything under the radical, 6 minus 7t, and we say it's greater than or equal to 0, okay? That's going to earn a check on a test. We're not going to quiz tomorrow or Wednesday. Now, here's what some people want to do. They want to say the square root of that is greater than or equal to 0. Nope. Nope. We're not trying to affect the output. We're trying to affect the input. The thing under the radical has to be 0 or positive, right? Now we set up an inequality that's linear. It's t to the first, so we know we can solve it algebraically, right? To do that, we separate the variables. And we like to have our variables on the left. So if we do that, no problem. We just have to remember that when you divide or multiply by a negative number, flip the inequality. So now I'm going to divide both sides by what type of 7? Negative 7. So I'm going to flip the inequality. Now, there's still opportunities for careless mistakes. Negative 6 divided by negative 7 is positive 6 over 7. If you need to show another step where you keep them both negative, and then you write whatever underneath there, that's fine. Okay, but I've seen errors be like 6/7, that's correct. But I've seen like negative 6/7. And of course, there's this one where your brain will betray you, like 7/6, right? You get the ratio wrong, or negative 7/6, okay? And then there's cases where you forget to flip the inequality. So you can see how I can come up with all kinds of answer choices that would be common mistakes. But remember, you can always catch your mistakes before you proceed, yes? We're saying that values smaller than 6/7 should work. All you got to do is try it out, and you can do this quickly in your head, okay? Plug it back into just the Radicand, right? We're looking for positive numbers or 0. Something smaller than 6/7 that should work. How about 0? 0 should work. 6 minus 0 is positive 6. Boom. Something that's not smaller than 6/7 that shouldn't work, like 1. 1 should not work. 6 minus 7 is negative. Got it. Okay? That's important. Always try to choose numbers that are immediately left and right. Here's what could happen. Watch. And I saw this on Friday with a very similar problem. If you have negative 6/7 and you remember to flip the inequality, watch what happens. Pick a number to the left of negative 6/7 that should work, like negative 1. When you plug in a negative 1, you get negative 7 times negative 1, which is positive 7, plus 6 is positive 13. Boom, go me, right? But now watch. Pick a number from the other side that should not work, something that's not smaller than negative 6/7, like 0. According to this inequality, 0 should not work. What do you get when you plug a 0 in, though? 6 minus 0 is positive 6. It works. And now you're like, ay caramba. Caramba, caramba squared. And then you find your, oh, a negative divided by a negative is a positive. And then you check again. Okay? So it goes a long way, checking. Now, that's just the demand of that one term. To work for the function, it has to work for all terms. So in this case, I got to check the denominator. So that would be the second thing. Take your entire denominator and say it can equal 0 or equal 0. I have a really bad short-term memory. So I'm going to go ahead and say not equal 0 because I'm constantly reminding myself, can't happen, can't happen, can't happen. These values don't work, don't work. So for us, that's t squared minus 25 can't equal 0. And of course, you could solve this one of two ways, right? You could bring the 25 across and extract both of the square roots, plus or minus. But remember, plus or minus, you have to remember to do that. And a lot of people forget. So I would just do this as, do your math homework, right? Is it due on Thursday? No, it's due on the day of the next test. But you want to DO it before then, right? But it's not DUE. All right, and so now you get T can equal 5, and T can equal -5. Now, a word about notation. Y'all are getting pretty good at working straight down, but once you start an inequality or an equation, you need to keep it all the way down. You need to see it all the way down. So on a free response or a short answer, make sure that you have it all the way down. A lot of times people just leave off the right side and then they bring it back somewhere in the bottom. Now, here's what you could do. You can just combine these two results. Here's what that would look like. D sub Q is the set of all T such that T is less than or equal to 6/7, comma, T cannot equal plus or minus 5, okay? There's nothing mathematically wrong with that. Nothing mathematically wrong with that. But you still might lose a point if you do that on the test, and I would deduct it and I would say for not thinking, -1 for not thinking, or -1 for being mean, okay? Yeah, right? -1, meanie head. Right? I mean, it's going to evoke some ire in me, right? Meanie head. Actually, I deserve to have a point deducted. If you're being mean and I'm calling you a meanie head because you're mean, there's a mirror right there, buddy. Pointing 3 fingers back at me for every one at you, right? But why is this mean? Let me show you. Let me show you. Let's say, hypothetically, and let's see how you feel, okay? Let's see how you feel. Mrs. Lincoln is going on a field trip. All of her class is going on a field trip. The whole class. We can't go, I'm sorry. But she's going on a field trip with her class. They need another chaperone. So guess what? Tomorrow, I'm gonna go chaperone with them. Y'all can't go, unfortunately. Her class is going, but I'm gonna help chaperone. Y'all are gonna be here with a sub, okay? You're gonna have a sub. So none of y'all can go. I'm so sorry. But especially you, Stephen, you cannot go either. You have to stay. You have to stay with everybody else that can't go, right? That's very mean of me. That's very mean of me to collectively say that none of y'all can go, but you're like, okay, we understand. But then Stephen, who's part of the group that can't go, I point out just to emphasize, and you still ain't going, buddy. I mean, why? That's just mean. That's what I'm doing right here. That's what I'm doing right here. Watch, I'm going to show you. If you draw this out on a number line, which when in doubt, draw it on a number line. Here's 0. Here's 6/7. Thank you for being such a good sport there, Stephen. You're not the best sport, but you're a good sport. If you were a better sport, I'd probably let you go. Anyway, thanks for being a good sport about that. If you draw these on a number line, watch. T can't be -5 or 5, so I'll put open circles around them. And then 6/7 is good. I'll put a solid dot, and then everything to the left. Very good. So I'm going to put a bracket this way, bless you, and I'm going to shade to the left. Now, when I shade to the left, there's no need to be throwing shade on 5, is there? This is what I just did. Everything in the inequality is Mrs. Lincoln's class. Everything outside the inequality is y'all. Y'all can't go. But look at 5. Is 5 even in the inequality interval? He's already excluded, isn't he? You only need to exclude the values that give you division by 0 if they fall in the interval, right? Otherwise, you're excluding them twice, okay? The inequality says that they're not going to be able to go, and then you stated, oh, and by the way, 5 still can't go. Ooh, no, don't do that, okay? Now, do we need to still exclude -5? Yeah, that's why you want to do your Radicand first. It gives you the chunk of your domain, but then you only need to remove values that fall in that interval that happen to cause division by 0. This -5 would be like someone in Mrs. Lincoln's class who thought he was going to go, but he forgot his permission slip. And now I have to tell him one time, I'm sorry, you can't go. You don't have your permission slip. You don't tell him twice, right? Or we're going to a peanut factory and this guy's allergic to peanuts. And so, sorry, your mom said you can't go. He's like, oh, that's okay. I'll just stay here and go in the other room and hang out with everybody and Stephen, because he's not going, right? Right. So anyway, does this graph make sense? You don't need to exclude the 5 because it's not less than 6/7. But -5 is, so you have to step over it, okay? So do your radicand first. So this is being mean. Don't doubly exclude. That's what I'm going to say. Don't doubly exclude values. There's nothing mathematically wrong with it, but it's not condensed. I want you to think, right? That's really the penalty. That's the whole purpose of math education, is to get you to think, right? So here's what you could say. Here's the correct answer. D sub q is the set of all t such that t is less than 6/7, comma, and don't use -5. It's the only one. Now try to make your braces correct as well. I know the intern was not good at making them, and he was just like, I'm not good at making them, you know. But you need to practice, right? You need to practice. No, I talked to him about it. Yeah, I'm not just throwing shade on him or under the bus. No, he needs to. Yeah, he needs to. He's a student too. You got to remember that. He's a student too. Now, here's a good idea. If you're not sure whether to doubly exclude something or not, just do interval notation. Because interval notation, there's no way to doubly exclude. Watch this. You're going to have t epsilon, -infinity. We have to step over -5, right? Like that. And then we cruise all the way up to 6/7. And then we have a beefy bracket. And then that's it. And you're like, well, what about 5? And you're like, we're not even going past 6/7, right? So your number line graph is kind of like your interval notation. Either one of these would be good. So remember, on a free response, you pick a notation. I don't care which one you use. But on multiple choice, I can use either. Here's another note. On the key, if you're looking at the worksheet key for the domain, if I did interval notation, I don't think I wrote x epsilon. I don't think I put t epsilon. I still want you to do that. I'm not going to take off if you don't, because if it follows the domain, it's implied to be input values. But remember, the whole goal is to communicate effectively. And if we can better communicate, why not, right? Why not? All right. Comments or questions on that? Do your math homework. Work practice tests. All right, that was the warm-up. Everyone warm? Yeah, I'm plenty warm. Thanks. Now, I know what you're thinking. You're thinking, hey, Mr. Corp, I thought it was Metal Monday, right? Did you give up already after one Monday of wearing Iron Maiden? Did I tell you? I told you my wife doesn't like me wearing them out in public because it scares people, right? So anyway, I said, can I wear my Iron Maiden socks? Yeah, and she's like, yeah, you can wear your Iron Maiden socks because people aren't going to see them, right? That's okay. But remember, she also leaves the house before I do. So I got Iron Maiden socks. This is going to show. Yeah. So anyway, after she left the house, yeah, Stephen, I kind of tiptoed back into my closet, and it, boom, yeah, there it is. Yeah, there it is. Yeah, there's Eddie from Aces High, and this is from the concert that I went to. Yeah, there's Pearl Snap. Yeah. If you try to do that on Pearl Snap, it's hard to close it, right? Because all the buttons fly everywhere. Yeah. But anyway, so I've got it. So yeah, Metal Monday, I'm going to keep it up. And Rage Against the Machine, that's awesome. That's good. That's good. And then K-pop, they sing a metal song, I'm sure, right? Right?
There's some bands.
Yeah. And Green Day, it's good. They're a Rock and Roll Hall of Fame. It could be like, what did you say? So, not Blueford, Music Monday. There you go. See, Music Monday. Yeah, Music Monday. Did you hear I called him out at the pepper? I called him Blueford. Yeah. So we'll celebrate good things. All right. Yeah, beefy brown. Now, one last thing here. I did move the bell. I don't know if you noticed, but people who are vertically challenged were having a hard time ringing it on the way out. So I put it above this hand sanitizer dispenser. So now you pull it out towards the room instead of away from. And I made a sign. I got the idea from Long John Silver's a long time ago. So I went to Google Images and I looked up what the sign looks like at Long John Silver's. And next to the bell, it says Captain's Bell. If we did well, ring the bell. And it looks almost identical to that. So I kind of copied it the best I could in Microsoft Word. But mine says Corpy's Bell instead of Captain's Bell. And it said, if all went well, ring the bell. So there you go. Now everyone, and I fixed the bell knocker, whatever you call it, with pliers, because some people were, you know, they did it so hard the bell knocker came off. But I don't know what you call it. But I crimped the bell knocker so it won't come off anymore. All right. Anything else for the good group before we jump into example 5? Ramones. There you go. Rock and roll. Music Monday. Ramones. I don't want to be buried in a pet cemetery. Right. Lola. Whoa, Lola. What's that? Oh. Come dancing. Let people have yourself a ball. And everybody come dancing. It's totally natural. Green Day. Right. Okay, good. Metal Monday. Whether you have to hide it or not. Are we at risk of dividing by 0 or taking the square root of a negative on this guy? Yes, we have a variable in the denominator and we have a variable under square root. Now, is this equation even a function? It doesn't have that name, does it? It doesn't say f of x, but it is a function. How do we know? It's y. That's y to the first is important, but more importantly, it's y equals, and there's no y's on this side. That's important, okay? So we did solve this for y as a function of x. If you don't give it a specific name, that's fine. When you do your domain, you can just do big D. You don't have to put the subscript. If you just want to put D sub y, you can. I'm going to give this fella a name, you know. I'm going to call him E of X for Eddie of X, right? Iron Maiden Eddie of X. I was going to leave it unbuttoned, okay? I wear extra large, but at the concert they were out, so I had to get a large. I'm like, but I'm a fat middle-aged man. They're like, that's all we have. I'm like, okay, I'll take it. $70, please. I'm like, no. I got it for $70. I stole it, yeah. But then before I left, I was like, you know what? I went to another table. Hey, do y'all have an extra large? We're out of extra large. I'm like, give me a double XL. And they gave me a double XL. So I have one like this with the double XL, but when I wear it, guess what? It's like, it's way too big and doesn't work well for an undershirt. So $140 on 2 sizes that don't fit me. I tried washing them together in the laundry to see if it would come out as an average one shirt with an extra, and it didn't work. Yeah. Anyway, what did you say about? Yes. Did you? Got to. Where did they come to? Dallas? Dallas. Yeah. Iron Maiden comes to San Antonio quite a bit. They got to finish up their tour from the summer before they tour with the new album. But I'll be there. Guilford and I are already standing in line, and we're going to take Braun with us this time. Okay. Here we go. Number 1, we're going to take the Radicand and we're going to say it's greater than or equal to 0. Put that sock on. Number 2, we're going to take the entire denominator and say it can't be 0. Put that sock on. Why am I saying sock? Because when you do in the morning, you put on maybe sock, sock, and then you do shoe, shoe. When you do sock, sock, you're setting up both inequality and equations, and you are giving yourself basically a check right away. And you're focusing on the setups. That's why you can do sock, sock. If you're one of those sock, shoe people, that's fine too. In the end, you got your shoes on and you're walking somewhere, right? So if you want to set up the inequality and solve it and then do that's fine too. All right, this is linear, so we can solve it algebraically. X is greater than or equal to a half. And we check it, right, before we wreck it. All we have to do is plug it back into the Radicand. Pick a number bigger than a half that should work, like 1. 2 minus 1 is positive 1. Boom. Something that's not bigger than a half, like 0. 0 should not work. 0 minus 1 is negative. Got it. Got it. Got it. Okay. Now we come over here, and that's hilarious. It's one of those funny things. And apparently it's from like a Dr. Dre song originally, right? Yeah. Well, the D's nuts, but then the Gotti's, yeah, it's from a Dr. Dre song, I believe. We can use the quadratic formula here, or factor, fingers crossed, factor. Yeah, factor. And again, once you set up an inequality, keep it at inequality. -5 plus 2, I believe, right? -5 plus 2, -10, -3. Okay, good, that works. Kaboom. Now we go straight to x can't be 5, do your math homework, and x can't be -2. Now again, do we want to say, Mrs. Lincoln's class is going on a field trip? No. And now these two guys can't come. Is one of these already excluded? We only need to exclude one of these if it's bigger than a half. Which one of those is bigger than a half? 5. So the -2 is already excluded. No need to exclude it again. So we'll say D sub E if you did that, or just D. It's the set of all x, such that x is greater than or equal to a half, comma, and don't use 5. You will lose points if you doubly exclude something. And again, if you're not sure, do the interval notation. Here's the way that would work. We're going to have x epsilon and greater than or equal to a half. So that's the lower bound, right? Beefy bracket, 1/2. We cruise all the way to 5, step over it. Boom. And now you're like, well, how can I exclude -2? You already did, right? -2 is way to the left of your starting point. It's already out. Okay. So in that case, like the warm-up, we had the possibility of both things happening. But unlike the warm-up, which was 2 separate terms, this happened on a single term. But no big deal. We still analyze them separately, and we amicably, nicely, intelligently combine our results at the end. Yeah? That's all we're doing right now, finding domains. Comments, questions? All right. Green Day's in the Rock and Roll Hall of Fame. Ramones are in the Rock and Roll Hall of Fame. Iron Maiden, not in the Rock and Roll Hall of Fame. They are in the Awesome Hall of Fame, though, which is Hall of Fame for being awesome. This function's name is M for Methuselah or Morris, whatever. The independent variable is T. Are we at risk of either dividing by 0 or taking the square root of a negative? Yes. In fact, this one is kind of a double whammy because now the radical is in the bottom. The entire denominator itself is the square root. Is this time to panic or just to proceed with the 2 steps that we've learned? 2 steps. We don't panic. So here we go. Number 1, the radicand, the thing under the radical, has to be greater than or equal to 0. Put that left sock on. Number 2, what part of the denominator can't be 0? The entire thing can't be 0. Put that right sock on. This is where students start getting confused. When do I include the radical? When I don't include the radical? Well, how have we been doing it? For the inequality, there's no radical. We're looking at the thing under the radical to make sure I can take the radical of it. Why am I including the radical on number 2? Because it's part of the denominator. And in the end, I don't want this output to be 0. I don't want this input to be negative, and I don't want this output to be 0, okay? So don't like write that down and then tell yourself, well, I guess this needs a radical as well, right? No, don't do that. Left sock, right sock, now we put our shoes on, right? And they could be as easy as slipping into some clodhoppers, or it might be something that requires a lot of laces. Here we go. If you don't want to divide through by a negative, here's what you could do. You could bring your term that's linear than negative, you could bring it to the right side. Did you know that? We like to have our variables on the left side, but you could bring it to the right side, and now you divide both sides by +7. And look what you end up with. 4/7 is greater than or equal to t. That's correct, but we like to read it the other way. So all you have to do now is flip it around on a swivel. But just remember that the alligator is eating the 4/7, okay? So it still has to eat the 4/7, and it's still less than or equal to. Okay? So if you think you're one that's going to forget to flip the negative, or if you're one that's like, I don't have time to test my answers at the end. I've got things to do, right? Let's test at the end. Something smaller than 4/7 that should work. How about 0, right? Plug it in right up here. 4 minus 0 is +4. That's good. Something that's not smaller than 4/7 that should not work, like 1. 4 minus 7 is -3. Yes, yes, yes. We got the inequality down. Now, look at number 2. This is called a radical equation, okay? Back in the 80s, they called all equations radicals, but that's the 80s, right? Dude, what a radical equation, dude, right? I told you they made a whole movie called Rad about a guy on a bicycle trying to do a backflip. This is a whole movie, like 2 hours of him going, try, try, try again. In Algebra 2, you learned how to solve radical equations, but it was during a pandemic, and it might have gone by like this. Whoa, dude, that was radical. What was that? So you might not remember. So I'm here to reteach you, okay? A radical equation involves a radical. To solve a radical equation, you need to, number 1, first and foremost, isolate the radical term. Have we done that? The radical term is already isolated. All right, number 2, probably the most important step. Copy and paste this. Number 2 is to square both sides. Now, when I say square both sides, does a bell go off in your head? Does a bell go off in your head like ding, ding, ding? Or does it raise a red flag? Do y'all remember anything that your teacher might have said or warned you about? When you square both sides of an equation, you got to be careful because something could happen. You remember? No? Okay, well, let's go off on a mathematical aside because even if you do remember, you may not have been told why. When we have an equation that's equal to 0, or in this case, a non-equation, we like things equal to 0 because y equals 0 is known as the x-axis. So let's, for the convenience sake, say we have a line, right? Something like this. It's of the form y equals mx plus b. If you set it equal to 0, you're looking for the x-intercept, right? That's what we call that. You're looking for an x-intercept. You're looking for a root, a 0, same thing. But sometimes algebraically, we need to raise both sides to a higher power to algebraically get at the answer, right? It's like you have a walnut and the answer's inside, so you need to like get the walnut cracker and you crack the walnut with the walnut cracker. We have a bunch of nutcrackers that we put out at Christmas. Like my wife collects them. And I was just thinking, I've never even used them to crack a nut. They just sit in the attic all year long until it's Christmas time. And then I put them up on the piano. And I'm like, what if I want a nut over spring break? I don't want to go to the attic. But I don't think those nutcrackers are really designed to crack nuts, right? You try to crack a nut and their mouth breaks. Ugh. But anyway, I don't know why I was thinking that. But anyway, here's what we do. We need to get at that root, but we need to get at it by algebraically squaring both sides. Well, if you do that, you might end up with something that looks like this. ax squared plus bx plus c. Algebraically, that quadratic will have the same solution you're looking for, that same x-intercept. But it also might have another solution that you don't want, an extra solution, if you will, that doesn't work. Does anyone remember what we call those extra solutions that don't work? Extraneous. Very good. Extraneous solutions. All right. So y'all did learn about it. Okay? Extraneous solution. The key word there is being extra. It's an extra solution. It's an additional solution. Neos, the suffix, means does not work. So extraneous means an extra solution that does not work. I have an Uncle Fred that's a lazy bum. He sits at home all day long and watches like Sally Jesse Raphael or Oprah Winfrey, and he picks up welfare checks. And so my Uncle Fred, we call him Uncle Neos. Uncle Neos, because you know what Neos means? Doesn't work. Yeah. So anyway, extraneous, extra solutions that do not work. So here's what we got to do. And I'm glad you remembered the term. If you ever square both sides or cube both sides, you need to check for extraneous solutions. Now, we're in the habit of checking already, aren't we? You could check any solution if you want to make sure that it works. But extraneous solutions, you could do the math completely 100% correct and still have a wrong answer. So it's not like we're checking our work to see if we made a mistake. We're checking to see if our correct work accidentally brought in an impasta, right? An impasta, which reminds me of another joke that I just made up. What do you call fake spaghetti? What do you call fake? An impasta, right? We're thinking alike. See, but Bluford is still the winner. Yeah. Okay, so let's go ahead and do that. We square both sides, and we get 4 minus 7t cannot equal 0. Square both sides. And so we get negative 7t cannot equal negative 4. And then we divide both sides by negative 7, and we get positive 4 sevenths. Now, when we divide an equation by a negative, do I need to flip the equal sign? You can, right? But when you flip an equal sign, it still looks like an equal sign. Now, if you put these together in your domain, let's check first. I'm sorry. We made that big stink. Let's check, right? Does 4 sevenths actually cause a 0? That's what we're checking. We're plugging this back up here into the blue part. Does it actually cause a 0? If it does, it's a legitimate solution. If it doesn't, it's extraneous. 4 sevenths times 7 is 4. 4 minus 4 is 0. The square root of 0 is 0. He's not an impasta. He's real spaghetti, right? Right? Yeah. That's like that reminds me of another joke I probably shouldn't say, right? Like, what do you call fake feces? There you go. Shampoo, right? Shampoo. I don't know why. Were you thinking of that one too, Stephen? No, okay. I've probably gone off the rails a little bit. But it works. So it's not extraneous. So now we can combine the results. Yeah. Shampoo for your friends and real poo for your family. The domain of M. I'm going to quit. I'm going to start doing math. It's going to be the set of all t that are less than, the set of all t such that, right? T is less than or equal to 4 sevenths, comma, t cannot equal 4 sevenths. Now, if you did this, I might take off 2 points because this is being extra mean. Would you agree? Because this would be like, hey, Mrs. Lincoln's class is having a field trip. Okay? I have to chaperone. Y'all cannot go. I'm sorry. Y'all cannot go. But I'm taking Haley with me. Haley can go. Mrs. Lincoln's class is going, and Haley can go. But Haley can't go. Now that's extra mean, right? Because then you're like, oh, I get to go. And then it's like, boom, right? You're saying, hey, T has to be less than or equal to 4 sevenths, but it can't equal 4 sevenths. Hey, guess what, everybody? I love peas and carrots, but I hate carrots. You're like, why did you even mention the carrots then, right? If you're talking about food you like, why say you like them just to say, no, you don't? This is extra mean. What's the best way to eliminate 4 sevenths from the domain? Take away the or equal sign. Yes. So this is extra mean. Here's what we're going to do. The set of all t such that t is strictly less than 4 sevenths. Done and dusted. Done and done. That's what we do. Haley never even gets her hopes up that she's going to go. Okay? And she's probably fine with that because she was going to hang out with her friends anyway when, So don't mention something just to turn around and take it away. Now, if you're doing it as an inequality, I'm sorry, that's fine. An interval, you're going to have t epsilon, negative infinity, up to 4 sevenths, parenthesis. Okay. There you go. So don't double exclude anything. When in doubt, draw it on a number line. Okay. Make sure that when you take the square root, you consider plus or minus. Make sure when you raise both sides to a higher power, you check to see if it's extraneous or not. Make sure it works or not. Okay? Questions on that one? All right, let's do one more. I have a square root with a variable, and I have a denominator. Oh, by the way, I did want to make one more point over here. If you work enough of these problems, you might actually notice from the very beginning, hey, I have a radical that takes up the entire denominator. So I can find the domain by saying 4 minus 7t is strictly greater than 0 instead of greater than or equal to. Is that what you just said? Yeah, yeah. And if you do that, you're going to get both checks that you would get from doing this down here. Okay. Now, if you're not sure when that works, don't do that. Set it up as two separate cases and combine your results. But when you do it as one, and it doesn't always work, then that shows me that you're thinking. You understand what's going on. Normally, the radical can have a 0 underneath it because the square root of 0 is 0. But in this case, it can't because that would make it the entire denominator. So we just take away the option of the radicand being 0 because the square root is 0, 0. So anyway, little point. Now over here, we're going to say negative x has to be greater than or equal to 0. And x squared plus 5 cannot equal 0. Right? Sock. Now over here, if we multiply both sides by -1, we flip the inequality. And now we test. X has to be less than 0. That means a negative number. Well, what do you get when you plug in like a -1 up here for x? -1 times the negative that's there makes it +1. That's good. Plug in a -2. -2 times -1, +2. Oh, yeah. And what about a 0? Does 0 work? 0 times -1 is 0. The square root of 0 is 0. Is 0 okay in the numerator? Yes. Yeah, it is. Some people just want to automatically all the time, x can't be 0. No, it can. When in doubt, try it out, right? Try it out, right? Like before you buy clothes from Amazon.com, you try them out, right? You go to the warehouse. I'm here trying some breeches before I buy them. I'm like, get it out of here, you're slowing us down. You can't really try them on from Amazon. But they do have something called Amazon Wardrobe where they can ship them, you try them on, you send them back, no big deal. X squared plus 5 can equal -5. When you extract both square roots, you consider plus or minus. Now look at this. The square root of -5, is that a real number? No. That's actually imaginary. We call that the square root of 5 with an I outside. The only values that make the denominator 0 are imaginary, which are actually real numbers. Not in the real number sense, but they're actually they actually exist. So if no real numbers make it 0, then all real numbers work. This has no restrictions. And you can see that in the graph. If you look at the graph of y equals x squared plus 5, here's what the graph looks like. There's 5, and the parabola opens up, right? And 0's down here. So the graph is never 0, is it? In fact, it's 5 units away from 0 at its lowest. So the moral of that story is, just because you have a variable in the denominator, are you going to have restrictions? Not necessarily. You can have variables in the denominator, and it's still never 0, like in this case here. But we still have this as our restriction, right? The radicand. So the domain of y, or just d, if you have y, you just put d, it's the set of all x such that x is less than or equal to 0. Or big D is negative, the set of all x, x epsilon, -infinity to 0 with the bracket. Just because you have a variable in the denominator does not mean you're going to have restrictions. Okay? We're not talking about imaginary numbers. The default number group this year is real numbers. Okay? That's a good stopping point, right? Yeah. Any questions, comments, quips, quotes, concerns? Tomorrow is Tie Tuesday. I'll be wearing a bow tie. If you want to wear a tie, feel free. I don't have to hide my ties unless I wear my Iron Maiden tie. Yeah. What's the last button on my notability? This one? Oh, this one. Oh, I don't know what that is. It's a recording?